Hey everyone, in this video I will show you how to make this Witcher sense effect. So it looks like this. Here if I press the button you can see the bushes are highlighted. You can also see a blood trail going through the world based on a spline. And here you can see that the rock is highlighted. And also here you can see sound waves coming through the wall. And no matter how far the enemy is, the sound waves kind of stays at the same size on the screen, and the quality of the effects won't degrade with distance. So if I get closer, you can see that they all look the same, and there is one that is very far away, it still looks the same as the ones that are closer. And here this effect is a bit more complicated than it looks, because when I let go of the button it needs to fade out like this, but if I press again it needs to fade in. But if I just rapidly press this, it shouldn't really pop in and pop out or cause any bugs. So if I press, it will fade in, and if I let go, it will fade out. But if I just press when it is fading out, it should fade in again. So it was a little bit more complicated than I thought. And here you can change the spline size. So the number of particles on the spline is set automatically. So if I just increase the length of the spline, it will still remain the same. So it will automatically calculate how many particles it needs for the new length of the spline. So you can create this trail how long you want. And also we can set the ratio. So if I increase the ratio, there will be less particles per spline, so like this. Or I can decrease the ratio, and if I set this to 1:1, then the length of the spline will be equal to the number of particles spawned. So now if I press, you can see the number of particles spawned. It is a lot. So I will just set this back to like 20. Now it looks like this. You can obviously change all of the colors and everything, the size of the particles, and you can set which appears to be red or green, etc. So if I want the bush to be red, I can just select the bush and here go to custom depth and change this to 1. So now the bush will be red also. So you can easily change which is which. And if you want to download the entire finished project files, you can support me on my Patreon. And for $5, you can get this project file and also almost all my previous project files from there. And if you are already my patron, thank you very much for supporting me. It means a lot to me. Thank you. So first we will create the spline effect. So for that, right click, then create a material and call it m_blood. Then open it up. Then here we need this to be translucent. So blend mode to translucent and shading model to unlit. Then we can get a radial gradient and a particle color node. And now multiply the RGB of the particle color to the radial gradient exponential. This node will allow us to get the color from the Niagara into our material. This radial gradient multiplied to the color will give us some depth to the color, so the edges will be darker. Now we can just connect this to the opacity, so we will get this soft disc shape. Now we need to distort this sphere to get a blood-like effect. So for that we can get a motion 4-way chaos, but you cannot get it from here like this. So there are like 2 ways to do that. My way is to just type in chaos, then normal from height map chaos, then open that up, then just copy it and paste it here. So this node, if I just open this up, it will just pan the noise texture we give in all direction. So we get this effect like this, and we can use that to distort our sphere. So here for the texture, we can get a normal map. So for that we can go to the starter content, then textures, then we can go to the water normal. This is kind of a big texture for our distortion, because for distortions we just need a really blurry normal map, but we only have this, I will just bring this into the motion forward chaos. But here if I try to connect this to the texture, we cannot do that because it only accepts a texture object. And to get a texture object, we can just right click and then convert to texture object. Now we can connect this to the texture here. Now for the speed, we will get a scalar parameter by pressing and holding S and clicking, and we can call this speed. So this will control the panning speed. And for divisor, we will get a scalar and we will call this divisor. This will control the intensity of the noise we get. So connect that to the divisor. Now we cannot really connect this directly to the UV. And if I just change the values, we won't really get anything we want. So to get something, we can get a UV coordinate by pressing and holding U and clicking, and add this with the motion forward chaos, and now connect this to the UV. So we will get an error since this is a 3 vector we are getting from here, and this texture coordinate is a 2 vector. It only has 2 colors or 2 channels, red and green channel. This also has the blue channel, and we don't really want that. So in order to just get 2 channels, we can just get a component mask, and here just pick R and G. We only need the R and G channel, and now connect this here. Now we are getting something like this, and now we can increase the divisor maybe a little bit, so we get something like this. And here if you just get a cosine node and 1 minus this one, we get something like this. And this is all we want right now here. And we can also get a scalar parameter and call that density. This will help us to control the size of our blood effect. So if I increase the density, you can see we can control the size like that. So this is all we want here. Now we will create the blueprint for the spline and also the Niagara system to render the particle according to the spline. So right click, then blueprint class, and then we can select actor and call this BP spline blood and open it up. And here we can just add a spline, this one, not the mesh. So add that and just click compile, and we can bring that into the world like this. And here if I go here and select this spline, I can just alt drag to create new points, and if I just need to increase the length, I can just drag like this, and if I alt drag, we can create new points like this. So I will create something like this for now. And now we want our particles to spawn across this spline, so we can shape it however we want. So for that, right click, then go to FX, Niagara system, then new system from selected emitter, and click next. And here we can get single looping particle and click add and finish. And we can call this NS blood trail, then open it up. Here for the sprite render, we can add our blood effect. Now we can go to the initialize particle, and here we can go to sprite rotation, and we can set this to random. And now we can go to color mode, and we can set this to direct set. And now we can just select whatever color we like. So I will just select this color, or we can select something like a bit more darker like this. Now we need to make this follow a spline. So for that, we can go to the particle spawn and click add here, add new module, and type in scratch pad, new scratch pad module, and we will go to the local module, and we will name this spline trail. And here we can click this add and type in spline and click spline. So we get a new spline. So here drag and type in sample spline position by unit distance world space. So this one, And here we can click this add and type in particle position. This will set the particle position using the spline and connect that here. Now for the U, we need to get the execution index. So this is like the index of the particle spawned. So the first particle spawned will have a value of 0. Then the second particle will have a value of 1, so on and so forth. So with this, we will set which particle goes where. And for that, we also need to get the count of the particles. So we can click here and type in int 32. This will be an input. And we can type in number of particles. And now we can divide the execution index by the number of particles and we can connect it here. And now we will just click apply and we will go to the system, and here we will go to the spawn burst, and here we will change the spawn count to 24 now, and also here we will change the spawn number of particles to 20. So now we will get something like this. And here if I go to the spawn trail, you can see a spline here. We cannot really input anything, but by default it will get the spline from the parent. So if I go to the blueprint and just drag this in, I will just drag the Niagara into the blueprint we created like this. We will get something like this. And if I click compile, so right now we cannot see anything, but we will fix that. See, there are like a few splines here and there, but I think the issue is mostly that these values are integer and that doesn't really work. We will first change this to like a float and see if that works. So it doesn't, so we can go back, and here we can just select the number of particles, and I will just remove that and I will get a float and just connect that and click apply. Now change this value to like 20. Now you can see that it is appearing on the spline, but it is disappearing. We can fix that. We can go to the blood trail and we can go to the emitter state and we can change the life mode to self, and we only need to loop infinitively and loop duration is 1 second. And we can go to the particle update and we can untick this so the particle won't die. Now we can go to the initial particle and we can here change the size to like 50 or something like that and click compile. Now if I just press play, it is staying like this, and if I go here it kind of disappears, and that is because of the bounce. So if I go into the particle and go to the properties, here the calculation bounce mode is set to fixed. We need to change this to dynamic, so it will recalculate that every frame. So now it shouldn't really disappear no matter where you look. One more thing we can do is that we can just create an instance from this and we can add that instance to the material. And then we can just increase the divisor so we get something like this. So I think I will just reset these values. And decrease the speed. So here one issue we are having is that the Niagara system is continuously making new particle again and again, and the old particles are not dying. So in order to fix that, we can go to the Niagara system. We can change this loop behavior to once, then go to loop duration mode, change that to infinite. So now we shouldn't have that problem. Now in order to set the number of particles using the spline length, we can go back to the Niagara system. Then we can go to the user parameters here, then press add. Then we can add a spawn count, which is going to be an int 32, and we can call this spawn amount and just copy that name and then click compile, and we can just go to the spawn, and here for the spawn count we can just drag that in, and here for the spline trail we can also drag that in, and as a default value we will set this to like 30 and compile. So it will look like this now. Now we can go to a spline, and here we can go to the construction script, and we can drag in the spline, and we can type in get length and get spline length, and we can drag in our Niagara, and now type in set int parameter, and here we will just paste the name we copied and connect this here, and here we can just divide this by a ratio, so connect that to the parameter. Now drag and promote to variable, and we can call this a ratio, and now just click the eye icon to make this visible in the editor so we can edit it. Now click compile, and now we will get nothing because the ratio value is 0. If we set this to 1, there will be a lot of particle, and if I set this to 20, we will get something like this. And now if I just increase or decrease the length, you can see that the density of particles remain the same no matter what. The only thing that affects the density of the particle is the ratio. So we can increase or decrease the ratio like this. So now we can make this a bit more random. So for that, go to the Niagara, and here we can click add and type in jitter position and set this value to like 25. So it looks a bit random like this. Maybe 25 is a little bit high, so I will set this to like 15. So now we have some randomness. Also we can add some randomness to the sprite size. So here I will go to the sprite size and set this to random uniform and change the values to like 25 and 55, 75. So now it's a little bit more random. Now we can go into the material, and here we can get something called a particle random node, and this will give us a random value for different particles. So we can get a ler and connect this here, connect this to the divisor, and get a multiply this by 2, then connect this here and connect this to the alpha and click apply. So now we have like different divisor values for different particles. We can also offset the texture coordinates using the particle random. So just connect that here like this. So we should just connect this here and connect this to the UVs here. So here we will just offset the position of this normal a little bit depending on the random value. So click apply, and now we can go to the trail and we can set a color. I think it's really bright, so I will just set that to like 3 or something like that. I think one thing we can do here is that we can just 1 minus this, so it is the opposite. So I think our particles are a little bit bigger, and we don't really want that. So we can go here and we can go to the uniform sprite size and change that to 50. And now we can select this and decrease the ratio a little bit, maybe this much. And experiment with these colors, so whatever you like. So this is more like blood, and here you can also change the density so it looks like this. Now we have this darker blood. The one I showed in the demo was really bright, but I think blood should be like darker like this. Maybe one more thing we can do here is that we can go here and change this to like 8 or something like that. So the difference will be really big. So yeah. Now some of them looks really distorted and some of them doesn't. So this is what we want. Now you can just select the spline points and just alt drag and then make it go and make it follow a trail. So now if I press play, you can see that it is following a trail like this. So this is what we want. You can obviously set the color to whatever you like. So now we will create the sound wave effect. So this one. So here I have created the sound wave effect using the widget. I tried using the Niagara, but you can see with the Niagara, the quality kind of degrades as I move away. The white is the Niagara one that you can see there. And it kind of gets smaller and degrades as I go far and far. There are ways to make it constant size, but I couldn't really get that to work in a satisfactory way, and they really didn't look that good, and they also tend to disappear sometimes randomly, even if I set it to render over everything. So we are not going to use Niagara for the sound effects. We are just going to use the widgets. So in order to create this effect, we can just right click, then material, and I will call this m_sound effects and open it up and change this to user interface. This is important because we are going to use the user interface to render the sound waves, so the quality won't be lost when we go far away. I tried to make it with Niagara, but it doesn't really work that well. I even tried to make it constant size, but I couldn't really get it working that well. So we are going to use widgets for it. So now change this to translucent. So now we can go to our blend and we can just copy all of this and paste it here. We don't really need the particle random value or the lerp or this add. Just connect everything back like this. And now connect this to the opacity. Now get a vector parameter by pressing and holding V and clicking, and we will call this color, and we can set this to like a white color for now and connect this to the final color. So we get something like this. Now we want this to be circular, and also we need this to grow in and out. So first we need to create our rings. So for that we can get a multiply node and get a frac node. This frac node will continuously create values between 0 and 1. So we can get a ring like effect with this. So if I connect this to the opacity, we get a ring like this. But now if we multiply this gradient, we will get more rings. So get a scalar parameter and we can call this rings. And I will give a value of 2 and connect this here. So now we have 2 rings. If I set this to 3, we will have 3 rings. Now we can just control the density to control the number of rings we have. Now here I will set the density to 1.5. So we get something like this. So now here if you round this, which means that every value below 0.5 will be rounded to 0 and every value above 0.5 will be rounded to 1. And connect this to the opacity. Now we get rings like this. So now how to make this grow in and out, or like make it like it is expanding? In order to do that, we need to add time to this one. So if we add time to this one, these values kind of move from 0 to 1 or 1 to 0, since center is 1, and then it will increase to 1.1, 1.2, 1.3, etc. Then it will decrease to 0.9, 0.8, 0.7, etc. as we move from the center to the outer edges. So if we add time to that, this frac value will make it move, because when we add time to it, the values kind of changes, and that will also make the frac values to change, and that will create a ring expanding like effect. So if I get a time node and get a multiply node And now we can get a scalar parameter and we can call this speed and connect this to the time, and we can connect this to the radial gradient exponential and connect this here and connect this to the multiply. So now you can see that it is growing like this. So here we don't really want this box like effect at the outer stages, so we can just multiply that with the original radial gradient, which is a really disc shape. So now we get something like this, and now we can change the speed to like 0.5 or something like that, or 0.72. Now we can control the size of the rings by having a power node in between the frac and the round, and we can call this size and connect that to the exponential. And if I set this to like 5, it will be really thin, and if I set this to like 2 or something, we will get what we want. So this is what we want. And now here for the divisor, we can set this value really low, like 0.1 or like 0.1.5, something like this. So this is what we want. Now click apply, and now we can create an instance from this one. And now we can also create a widget. Go to user interface, widget blueprint, then user widget, and I will call this widget wd sound. Then open it up. Here we can just drag our material in and go to the full screen here and set this to desired. So it will be really small, but don't worry, we will set that back later. And now here you can change the color to whatever you like. Since we gave a white color here, while changing the color it will just tint it, so it looks like this. So we can just easily change the color like this here. Now we will create the post process effect. So for that, right click, then go to material. I will call this m_sense post process, then create an instance and open this up. Now set the material domain to post process and search for blend mode and change that to before tone mapping. If you don't do this, because of anti-aliasing, we will get a jittery image when we do some post-process effects on it. Now right click and get a node called scene texture and get post-process input 0 from here. This is our normal post-process effect. So if I just multiply some color with this, like this, we will get an error because this is a 4 vector. So we need to just mask this and make this a 3 vector. Now connect this. So we will get this red color. Now for testing, I will add this to the post-process volume, but later I will show you a way to add this using Blueprint. So this post-process material won't run all the time when we don't really need the Witcher Sense effect. So right now we are just adding it for testing purposes. So go to the post-process volume or just add it from here and then go to the post-process material and add an array like this, and then just choose this material like this. So we get this dark red color onto the world. So this is what we want right now. Now we need to highlight certain objects with different colors. So in order to do that, we need to go to the project settings. Then here type in stencil and go to custom depth stencil path and select this and select enabled with stencil. So now we will get like a 256 number of IDs that we can use to give individual colors to individual objects. So now here we can just move it here and now get a lerp by pressing holding L and clicking. Connect this here and connect this here. Then connect this to the MC color. So now we get something like this. Now just duplicate these. And here we only need the R value. I now change this to custom depth and then just duplicate this. I now just change this to scene depth. So we will just subtract the scene depth from the custom depth. So we will get individual mask. So we will just subtract that. Then we will just seal this. And so every value is either 0 or 1 for an integer. And if you saturate this, the value will be clamped between 0 and 1. Now if I just connect this to the MC color and click apply, you can see that some objects in the world are black. And if I just go to the props and select this rock and bring it into the world, it is white right now. But if I search this and type in custom and pick custom depth render path, it will be black. So if you just 1 minus this and connect this to the alpha and connect this to the MC color and click apply, you can see that this is darker. So now if I just select this color and click apply, you can see that it's glowing because we have masked that out from the world. And here you can see that the sky is glowing also. So we need to implement a sky mask. In order to do that, we can go back to the post-process material. So now here we have a scene depth. This is like the distance from the camera to the world. So if we get an if node, and here we will set the distance to like a very large distance. And if the scene depth is greater than this distance, we will get a 1 value, and otherwise we will get a 0 value. So now if I just connect this here and connect it here and connect this here and connect this to the alpha here and click apply. So here you can see that only the sky has the orange color. So all we have to do is just reverse this like this and bring the 1 in here and click apply. So now the sky isn't orange, but our rock and bush is. So here I will just duplicate this rock again, and now I will set the custom depth stencil value to like 1. And now we need to give different colors to the different rocks. So this one has a value of 0 and this one has a value of 1. So in order to do that, we can go to the post-process material again, and here we can just bring this down, and here we can type in stencil mask compare, and we can get a ler, and this one will be color 1, and we can get another vector parameter, and we can call this color 2. So this one we will set to like a blue color like this, and connect this to the B here, and connect this to the A here, and connect this to the multiply here, and connect this to the alpha. So for the ID we have to compare, we will get a constant by pressing only 1 and clicking, and set this value to like 1. So if the stencil value is 1, this will output a value of 1 and we will get a blue color. And if it is 0, it will output a value of 0 and we will get the output of the ler path A here. So we will get an orange color. So if I click apply, 1 is blue and 1 is orange. And if you want one more, you can just connect it like this and just duplicate it and set this to 2, and now connect this to the B here. So this is 1, which means a value of, which means a color of white. So now if I just set this to 2, it will be nothing because there won't be any color. And if I just select the, if I change the value to like 22, it will be brighter like that. So we can go on and on like this up to like 256 values. So I'm just going to delete this. We don't really want that. Now click apply, and I will set this to like 1. So now this is what we have. Now we need to make this move a bit and add some sort of distortions to it. So in order to do that, we can go to the post-process material again. So here we can just drag this and type in reroute, and we can call this main output or main color, and then we can just disconnect all of that and connect this here, and here we can just type in main color and just connect this like this, so it will be a little bit more cleaner. And then we can just duplicate this. We can bring it here, and now we can get an add node and connect it here and connect this here. And we don't really want this multiply. We will get a lerp and connect this here and connect this here and connect this to the lerp here. And for this one we'll get a Fresnel, and for the normal we can just duplicate this one, and here we can get the world normal and set this to and set the base reflect to like 0 and click apply. So now we get something like this. We can also change the exponent to like 15, so it will be more sharper. So now we have something like this. We can also reduce the intensity of these colors a bit, so I will get a multiply and then give a value of like 0.5, or you can set the values here directly. So the brightness has reduced a bit, so this is what we want. Now to make it move a little bit, we can distort this world normal like we did for the blood effect. So in order to do that, just get a screen position and now get an add node and connect this here, connect this to the UV here, and here we need to get a texture. We can use the same old water texture that we have, this one. Bring that in, get a panel, and now get a component mask because we only need the R and B channel, and get a multiply. This will control the intensity, so get a scalar and type in intensity, and I will give a value of like 0.34 now and connect this here and connect this here, and now we can connect this to the panel and give a value of 1 for Y and click apply. So now you can see that it is moving really fast. This is probably not what we want, so we can go here and give a value of like 0.3 and click apply. So this is what we get. What we can do now is that we can just get a multiply and connect this here, and now we can control the tiling of this normal map. So press and hold S and click, and we can get this scalar parameter and call this tiling, and here we will give a value of like 5 or something like that. I think that's a bit too much, maybe like 2. Okay, that's actually fine. So now if I press play, you can see the effect. I think the intensity is a bit too much, so I will just set this value to like 0.1, and here I will set this value to like 0.1 also and click apply. So we get something like this. We can also make this texture blurrier by going into the MIP value mode and changing this to MIP level, and the constant MIP value we can set this to like 7. So now you can see that it's really blurrier. Now if I click apply, so now we get something like this. Maybe here we can change the tiling to like 5 or something like that, because it's really blurrier. So that's how we create the post-process effect. So now if I just select this bush, and if I set this to like 1, it will be blue, and 0, it will be this one. So now we can get another lerp. So now we will get a collection parameter, so we can manipulate these values from the blueprint. So now we can connect this here and duplicate this main color and connect this here. And now we can go to the content browser, then here right click, then go to materials and material parameter collection. I will call this PC underscore data and sense. Then open it up. We just need to add a scalar parameter, and we can call this alpha. And now go to the post process, and here we can type in collection parameter and change this to alpha and connect to the alpha here and click apply. So now it is invisible, and if I set this value to like 1, it's visible. So now we can just remove this from the post process and we can add this using blueprint. Now we will create the blueprint to control all of this. So we can go to the third person character blueprint here, and we can just duplicate this and call it something else. So this will be the monster. So I now bring that into the world like this and open that up, and here go to the viewport, and now we can add the widget we created to this one. So this widget sound, we can add that here, or just type in widget, and here for the widget class just click that, so we get this like this. So now if I just compile and if I go behind the wall, we cannot see the sound effect. So in order to see that, we can go to the widget again and change the space to screen space here. Now for the draw size, we can give a size of 150 by 150. And another important setting is that here in the tick mode, change this automatic. So the component ticks only when it is visible, and we will control that using the blueprint. So just change that to automatic. This is for optimization purposes. So now click compile. So now if we look, we cannot see the effect, but if I hit play, you can see the effect, and it is also visible through the wall, and this is what we want. So now we will create the blueprint for the control. So for that, we can go to the third person character blueprint, open that up, and here go to the begin play and get a sequence node. So we don't really affect anything that is happening here. And here we need to store the default camera length of the camera boom and also the default field of view. So we can reset it back after the effect is finished. So just drag in the follow cam also. Then here type in get arm length, and here for the follow cam drag and type in field of view, and we can get the field of view. We can promote this to a variable. So this will be the default arm length, and we can promote this to a variable, and this will be the default field of view. Now here we can type in R keyboard event and get that one here. Now we need to create a timeline, and we will call this animate alpha. Now connect press to play and release to reverse, then open the timeline up, then change the length to 1 and add a float track, and we can call this track alpha. And now shift click here and set this time to 0, and shift click here and set the time to 1 and the value to 1, and then we can just use an auto curve so it looks smoother. Now here we can get the stored arm length, we can also get the stored field of view, and now we can get our camera boom and the follow cam. And for the camera boom, we can drag and type in set arm length and connect that to the update. And for the follow cam, we can drag and type in set field of view and connect that here. And here we can drag and type in lerp. Here also we can drag and type in lerp. So this will lerp the value between the default arm length and whatever we give. And here this will lerp the value between the default field of view and whatever we want. So we can connect both of them to the alpha. So when it starts playing, it will go from 0 to 1. That means the output will go from A to B. So here for the B of the arm length, we can give a value of 100. And here for the field of view, we can give a value of 120. Now if I press play and press the R key, you can see that it is going closer to the player, and the field of view have changed also. And if I press R again, it will go back like this. So it is really smooth. If I continuously press and release, you can see that it is really smooth. It starts and stops or reverse from where we stopped previously. So that's really smooth. So now to add the post-process effect to the camera and not to the post-process volume, because we don't really want the world's post-process volume to render that material all the time when we are not really using it. So we need to discard them after we use it. So we can add the effect to the camera itself. So now to add the post-process material to the camera, just drag this in, drag and type in set post-process settings, and then we will drag and type in make, and now here we can type in material, and now select this one, and here in the search type in material. So now we will add this as a pin, and here we will drag and type in make weight blendables, and here we can type in make array, then drag here and type in make weighted blendables, and here set the weight to 1, and for the object we will get the post-process sense instance and add that here, and now we can just connect it here and connect this to the play. Now select all of this and right click and call up to a function. So we can call this post-process setup. So now we have a function that adds our post-process material. Now here we can type in set scalar parameter. So remember we created a parameter collection for the post-process effect. So we will just set that here. So PC data sense and the alpha. And now we can connect the alpha here from here to here. And now if I just press R, you can see the effect. And if I release R, it is disappearing, but that is because of the alpha. But this is still rendering in the background. We don't really want that. So we need to remove the post-process material. So for that we can create a bool, and we can call this post-process enabled. And when we press, we need to enable it and tick that. And when we release it, we need to disable it. So when the timeline finishes, we can check using the branch if the post-process is enabled or not. And if it isn't enabled, we can just duplicate the post-process setup. And here we can just go in and we can connect this here and click compile. Now we will go back. So it will be set to nothing. And here we need to just reset that to the Witcher sense. This one. So now when we finish using the post-process effect, it won't be really rendered on top of the camera anymore. Remember, if the alpha value is set to 0, it is still calculating everything in the post-process, because that post-process is always running. But now when we set this to nothing, it will just discard that post-process material once it is finished using. So that's what we want. So here you can see that the sound effect is always playing, but we don't really want that. We only want that when we press the R key like this. So in order to do that, we can go to our widget, then we can go to the graph, and here for the event construct, we can just right click and type in self, and here we can type in visibility. So set visibility and connect that here, and in visibility change this to collapsed. You can also use hidden, both will work. I will just use collapsed. So now if I just press play, you can see that it isn't visible. So now we need to make it visible using the blueprint. So in order to do that, first thing we have to do is that we have to go to the monster, this one, and go to the widget, and here we need to add a tag, a component tag. So this tag will be called sound effects, or we can just call this tag sound underscore widget. So I will call this sound underscore WD and copy that, And now go to the third person character, and here we will create an event. So right click and type in custom event, and we can call this trace for monster. Now we will do a multi-sphere trace by object, and here we can just make the object type to a pawn. So our monster is a pawn, so we want to trace that. And here for the start and end location, we can just get this capsule component and type in get world location and connect that to the start and the end. And for the radius, we can set this to like 5,000 or something like that, or you can create a variable and set this whatever you want. Now for the actors to ignore, we need to create an array, and we will call this actors to ignore underscore monsters. Now we need to get a branch and connect this here and connect to here. So only if it hits something of the class pawn, we will do the rest of the stuff. So here we can just do a for loop. So it will loop through everything that has hit, and we can break this. And now we can just drag in the actors to ignore, and we can get an actor, hit actor here. And here we can drag and type in contain. So let's see if we already hit this actor or not. If we haven't hit this, we can just do the rest of the stuff. So get another branch, and if this is false, we will do the rest of the stuff. So here we don't really have to connect this here. We can just disconnect that. If this new actor isn't inside the array, we need to add that to the array. So type in add, and we can add that. So this will prevent multiple hit on the same actor. So when the sphere trace hit, we will just check if it is already present. If it isn't already present, we will just add that to the array. So next time it hits, it will be inside it and it won't be false. So it won't be added again. So that's what we are doing here. And then drag from the hit actor and type in get component by class. And the class should be widget component. So because the widget component is this one that we added for the sound effects, and also just copy this sound WD name. So if this is valid, if our pawn has this component, we can do an is valid check. And if it is valid and it has that, we know that the pawn we hit has this component. We can check if it is the same component we want. So here we can type in has tag and component has tag, and here we can type in the tag. So sound WD. And if this is valid, and if this is valid and also has this tag, we can proceed to the next thing. So right now I will just print, and we will just type in hit monster. And now if I press play and press R, I will just go here. Wait a minute, I need to connect the trace for monsters here. So I will just drag and type in trace for monsters. Add that to the R keyboard event. So now if I press play and if I press R, you can see that there is 2. And if I let go and if I press R again, it won't be visible because we haven't really cleared the array. So if we just clear the array, next time we press the trace for monsters, this array won't have anything. So it won't contain the 2 actors we hit previously. So now if I press play and press R, it is visible. Now if I press R again, now you can see that it is visible again. So we can now from this tell that it has a widget component class, and also that widget has a tag of sound WD. So if it has both of them, we can just drag and type in get widget, and here we can again drag and type in cast to WD sound, the one we created. And here we can go to the WD sound, and here we can create a custom event. We can call this show widget, and now we can create another custom event and we can call this hide widget. So here for the show widget, we can just duplicate this and select this and then connect that here and change this to visible. And for the hide widget, we will get a retriggerable delay and give this a value of 1 because we only want this to hide after 1 second because our timeline is 1 second. So if you change the timeline, we need to change the delay also. So after 1 second, we will just collapse this again. So collapsed. Now we can go back to the blueprint and here we can drag this one and type in call show widget. So now we can create another custom event and call this deactivate sense. So we will use this to deactivate all the senses we created. So for this we can also get a for loop, and for this we will get this array. And now for this we can just copy all of these and paste it here like this and connect this to the target here, and here we can type in deactivate or hide widget. So now we need to call this deactivate sense from here. So drag and type in call deactivate sense. Now press play and now press the R key. So you can see the effect. Now if I release the R key, you can see that it has disappeared abruptly. We don't really want that. So we need to really fix that. So in order to do that, we can go into the sound effects here and get a multiply. And here we can right click and type in collection parameter and change this to the PC data sense and set this to alpha and then connect it here. And now click apply. Now if I press the R key, it will fade in and fade out. If I press it continuously, you can see that it might disappear. So in order to fix that, we can go to the widget and here we only want to set the visibility to collapsed if the scalar parameter value is equal to or less than 0. So here we can type in get scalar parameter value, and for the collection we can get the data sense we created, and this is alpha, and we can type in less than or equal to, and here we can give a very small value of 0.01, and only if this value is below that we will collapse the widget. So it won't be collapsed if this value is above 0 because at that time the widget will be visible and we want to see it. And now if I just press play and press the R key like this, you can see that it is visible, and if I let go of the R key, it fades out. If I press again and go, it will still work really well. It won't really disappear, but after we fully let go, it will be collapsed. So that's what we want. So now we have our Witcher sense effect working, both the sound and the highlights. Now we will create the blood. So to create the blood spline effect, here you can see that I have done it in a different way. If I just select the blueprint for the spline, you can see that there is a sphere, and with this sphere I can increase or decrease the radius, so where this effect should be playing. So I can individually control this. This can also be done with sphere trace. So I thought it will be better to give the range control into the blueprint of the blood trail itself, because you probably only going to be following one blood trail. You probably like to set the sphere in which the blood trail is visible or can be activated. So it can be individually controlled. So that's what we are going to be creating. So in order to make this, we can just select this one and we can open the blueprint editor, and here we can go to the event graph I mean, first we have to go to the viewport, and here we can add a sphere collision, and we can just increase the radius a little bit, and here we will select overlap or dynamic, and now we will go to the third person character. So now in order to do this, we need to add a sphere collision here also. So go to add collision, then sphere collision. This just needs to be really small, it doesn't really matter the size. We need to add a tag. We can give it a tag of blood sphere or something like that. Then we need to just copy that. Then we can go to the event graph. Then we can go here, trace monsters, and get our sphere collision, and type in set collision and collision enabled, query only. Then here set collision type to world dynamic, and here in the sphere we need to set the collision preset to no collision. So now after this loop is finished, we need to set the collision to set collision enabled to disabled, so no collision again. So after this is completed, so now if I just increase the size of the sphere like this, and I can move it here, and now go to the spline, and here on component hit we can drag from overlap component and type in hashtag and paste that in blood sphere. Then we will get a branch, and then we will just print a hello if it hit it. So now if I just press play and press R key, so nothing is happening right now. So let's see what's wrong. So I think we need to connect this to the overlapped. We need to connect this to the other component like this. Now let's see if it is working. So now you can see the hello, so it is working. So now we can use this to activate and deactivate. So we can go here, and now we can select the Niagara, and we can type in activate, and here we can go to the Niagara and type in auto activate and disable that, so untick that. And here we can also select this sphere again, and here on component end overlap we can go here, we can just duplicate all of these and connect this here and connect this to the other component. And here we also need to do a retriggerable delay. So what a retriggerable delay does is that it works like a normal delay, but if there is another input coming, it will just reset. So if this is 1 second, it will wait for 1 second to fire this event, but before the 1 second, if there is another event coming, then it will reset again and wait till 1 second. So since our timeline is like 1 second, we need to set this to 1 second. So we need to wait 1 second till we deactivate the Niagara system. So here we can type in deactivate, and now if I press play and press R, you can see that it is appearing, and if I release R, it will just disappear after like 1 second, I think. No, it is not disappearing. So, and it is creating multiple effects, so we need to fix both of that. So here we need to do a different activate, so drag this and type in activate and set activate. So we need to get this activate and connect that and tick activate. Now let's see if it is working. So press R, it is activating, and deactivating it does nothing. So we need to fix that. We can go to the Niagara blood trail effect, and we can go to the particle update here, and we can expand this. So here we have to tick this let infinitively lived particle die when emitter deactivates. So tick that. So now if I just press play and press R, it appears, and if I let go of R, it still doesn't do anything. So let's see. So one more thing we have to do is that we have to go to the Niagara system, and here in the emitter updates, here in the inactive response, change this to kill emitter and particle die immediately. So now if I press play and press R, and here if I press R, you can see that it appears instantly, and if I let go of R, after 1 second it kind of disappears really fast. So we don't really want that. We need them to fade in and fade out. So in order to do that, we can do the old trick that we did to the widget material. So we can go to the blood material, and here we can type in collection parameter, and we can get the one we created and get the alpha. Now get a multiply and connect this and connect this to the B and connect that to the opacity and click apply. Now if I press play and press the R keyboard event, you can see that the blood is appearing, and if I let go of the R, you can see that it fades in and fade out. And if I continuously press it, it doesn't really, okay, there's a bug. So in order to fix the bug that caused the blood to disappear suddenly, we need to go back to the spline blood, and here we need to do the same thing we did with the widget. So here we can type in get scalar parameter, and if this value, this data sends alpha, only if this value is less than or equal to 0.01, then we can deactivate the Niagara. Only if the Niagara is invisible or the material is invisible, we can deactivate it. So now if I press play and press R again and again, you can see that it should work and it shouldn't really disappear. And when I let go of the R, it will fade in and fade out. And since we can set the sphere radius like this, if I just go here and press play and press R, you can see that it isn't appearing at all. But if I go here and press R, you can see that the blood trail is appearing. So yeah, I think that's it for the tutorial, guys. Thank you very much for watching.